Hello programmers. In this video we continue our discussion of the TreeView control. I have a complete functional project I want to discuss with you. You should be able to download that from the LMS. You will need the VPN up and running to run the project. If you haven't done that, you should stop the video and start the VPN now. This project connects to our database server, submits a query, receives the results, and uses the results to populate a control. As you might guess, the control is a TreeView. Amazing how that works out, huh? When you run the project the first time, it will crash. That is to be expected. We will fix that in a moment. I will demonstrate that here. If you get this far, you have connected to the database server, you have downloaded some information, and during the processing of that information where you are loading it into the TreeView, it crashes on you, and that's okay. We'll fix it, don't worry. Close that execution of the project. We're back in the code again. I created a subclass of tree node. Remember, the tree nodes are the individual elements that populate the TreeView control. And I created a subclass of tree node called myTreeNode. And then I added some functionality to that subclass, particularly in the constructor of myTreeNode. It accepts a string that it will use to populate the text property of that tree node. And inside that constructor, it validates a minimum length of that node text. If the minimum length is not met, it throws an exception, and that was the yellow screen that you saw a moment ago. And you can study that code. It's in the project that you downloaded. It's also here on the slide. And I want to talk a little bit about software engineering and design patterns at this point because it's a good jumping off topic for us. Also notice at the bottom of the slide, at the bottom of that TreeNode class, there is a destructor. We never talked about destructors in Java because there aren't any. The Java JVM decides when to destruct something. In C# and in C++, you have a little more control. In C++, actually, you have total control. You have to decide when to run the destructor. In C# there is also a default destructor for you if you don't want to implement your own. In our destructor, which is called when the object goes out of scope, you don't have to worry about calling it, I decrement a counter. This is solely to demonstrate that I can manage a static variable that is common across all instances of my tree node, and I can use that static variable in this case to keep track of how many tree node or my tree node instances have been created in my program. Again, if you look at the constructor, you can see count++, which increments the number of tree nodes being created because that gets called each time the constructor is called. In the destructor, which gets called each time an object goes out of scope, it decrements the counter. I'm not doing anything else with this counter. Your takeaway from this should be that we can have a destructor and we can have static members of a class, and those static class members are common across all instances of that class. There's one copy of count, and all the instances of my tree node have access to that one copy of that variable. Another static variable I created in this class is min name length, and I set that to 10. I only need one copy of that because it's a common value across all instances of this class. I want all instances of my tree node to be at least 10 characters wide in the name property. There's no reason to create a copy of that variable for every instance of the class. It's better to use a static variable that is shared. Every time I create a myTreeNode instance, it will have access to the copy, the single copy of min name length. Returning to the slides again, I provided a UML diagram to give you another perspective on the subclass that I wrote. The base class is system.web.ui.webcontrols.treenode. I omitted all the many properties and methods of that class just for brevity. And then inheriting from that class, I have myTreeNode, which you saw in the slide and in the code. You can see that underlining a property of a class makes it static. Okay, that's our UML convention. And then in the properties list, in the methods list, I indicate that I have a constructor that takes a string as an argument and a destructor that takes nothing and returns nothing, as only a destructor can. You can't have arguments and you can't have return values in a destructor. It wouldn't be possible to do that. The destructor always starts with a tilde, which is a logical not in some systems. So when you see a tilde, think logical not, or the opposite of constructor, which we consider to be a destructor. And that's my simple class diagram that illustrates what I implemented in the project that I gave you. And I am asserting weakly, I'm not very strong about this assertion, that my tree node is a wrapper class because it provides additional functionality and pretty much encloses the tree node class that it inherits from. And this is a little bit iffy if you study design patterns and you read the literature. There's always some disagreement. There's always a set of rules, but they're not perfect. So I would be very willing to hear other arguments about whether it is not a wrapper class, whether it's some other type of design pattern, and that's fine. I'm not going to post this on Stack Overflow because I don't want to get into a big debate over what design pattern this might happen to be. If you'd like to do that, feel free. I'd be happy for one of you to jump on SO, formulate a well thought out, well formatted question, and see if anybody else is willing to jump in and beat us up over whether this is actually a wrapper class or not. Also notice that I sourced our wonderful friend Wikipedia on this slide, which we have very little faith in. And even this Wikipedia article admits that it might not be very good. It's got a warning there at the top. And I did point out that this is a very general description of object-oriented programming in this Wikipedia page. And when you see the word interface, that jumped out at me as I read it. That's not a C# interface. That's a generic term for the way to talk to a class. So I highlighted that. And if you click on that, you can read that an interface really is used in a different generic sense than it is in our specific programming sense that we've talked about interfaces. The argument could be made that this design pattern could be a decorator. Again, fine. I'm not wedded to the fact that it's a wrapper, but I'll be happy to consider other options as well. An excellent book about design patterns, as I think I've shown you in class, is this book. I have a copy of it. I would be happy to show it to you right now, but I probably don't have it available, as you might imagine. And it's reasonably inexpensive. It comes with a built-in bookmark which is kind of neat. It's the only book I've ever seen that has a bookmark attached to it, which is unique. And it's written by some very famous people in the computer science and software engineering fields. So if you have the inclination, take a look at it. It is deep, it is hard to read, and it will take you time to get through. It's not a novel, you don't read it for entertainment. I say pick out a chapter, study the daylights out of that chapter, implement some code according to that chapter, and then perhaps move on to the next chapter at a later date. It's not something you sit down and read from beginning to end unless you're way smarter than I am. Okay, that brings us to the end of the slides. Let's jump into the code and take a closer look at the code and actually fix the problem that we had when it crashed earlier. Here's our code. I'll run it again before making any edits. Let's take a closer look at the error message that pops up. The error message says, my tree node, node name must be at least 10 characters, and then employees, in quotes, is invalid. Well, that's an error message that originates in my code. My tree node class throws an exception. The definition of the exception is that line of text, and that line of text makes it through the .NET framework and back to the end user in the form of a web page. Remember, we are in debug mode, so .NET happily displays a fragment of your code to show you where that error took place, where that exception originated. You certainly don't want to deliver a project that's configured to run in debug mode. That would be an absolute disaster. So before you run something off to production, make sure you put it in release mode and make sure that you are positive and that you understand that nothing is going to be displayed as far as jumping into the lines of code. All right, we'll close that execution. And we're back to our program again. I'm at the page load event of the code behind on the default.aspx web page, which is the only web page in this project. In the page load event, it checks to see if we're in a postback mode. If we're not in postback mode, it calls a method called init TreeView with stores. That means that this method only gets called once because the page load is only going to run once in a session and not be in not postback mode. So every other time page load runs, it will be in postback mode, and init TreeView with stores will only run that very first time. Before we run it again, let's just flip back over to the my tree node class, and let's change this minimum length to just change it to 1, and that way we're not going to crash anymore. After making that change, let's run it. We should not get the error message now. It should connect to the database, download some data, and populate the TreeView control. It seems to be taking a little longer, and I think that's a good sign. Or maybe not, I don't know. Alright, we didn't get the error message. The TreeView appears on the web page. I can open it. It has populated the TreeView with every employee in the employees file and created a subnode on each employee representing the store to which that employee is assigned. And this is a query that joins the employee table and the store table because I need the employee's name from the employee table and I need the store name from the store table because store is a foreign key in the employee table. I have SSMS open. and I've connected to the database, I can look at Grocery Store Simulator. That's what we're connecting to. And in the employee table, there's a foreign key called Store ID. That connects to the primary key in the store table, and that is the way we join those two tables together. And I'm going to kill this execution and go back to the exploring the code again. Let's take a closer look at init TreeView. The init TreeView establishes a connection, submits a query, receives the results of that query from SQL Server, and processes that query one row at a time to add things to the TreeView. Now I think I'm looking at the wrong one. I actually want to look at init TreeView with stores. Scroll down a little bit. That's the one I'm interested in. In line 46, it creates the query. It's a little bit unwieldy. I had to break it up into multiple lines. I would have been better off using a view and having that view stored on the SQL Server side and then submitting that view from this code, but I wrote a query instead. So not the most efficient way to do the job. A better way would have been to create that view. There are no parameters in this query, so I don't have to be parameterized. It's not a SQL injection problem. So I create a command object which models a SQL statement or a SQL command, for lack of a better term. I open the connection. The connection references a connection string in the config class. I'm not going to show that here because it's got the password in it, but you can look in the config class of this project and see the connection string. I stored the connection string in a separate class to make it available to other classes in this project, or even to be able to move it to another project without having any little roots sticking out of it. Once I've opened the connection, I execute the execute reader method, which submits the SQL in the command object to the database engine. Keep in mind that all through this code things could go wrong. If the connection fails, if the credentials are wrong, if the database host name is wrong, if the URL is wrong, if the connection dropped, if the VPN is not running, all number of things could fail. So I'm really going out on a limb and assuming that everything is going to go perfectly. You'll notice there's no try catch in here of any kind. Error handling is not that great in this method. If I make it to line 55, I have managed to open the database, submit the query, and then receive back whatever results came back from the database engine. Whether there were results or not, I don't know yet, but it sent me something back and it didn't crash. I call the read method to step through the rows in the result set one row at a time, and then I loop through all those rows, processing each employee once and processing each store within that employee once, and then at the end collapsing the tree, which may or may not be a good idea. That's kind of a separation of concerns issue here. I really probably shouldn't be doing that. Once I've collapsed the tree, I return and my tree view has been populated, and that will be rendered on the client side in HTML and JavaScript, which is a really big mess if you look at it. Let's do that. Let me run this again for you. It ran. My code populated the tree view control. My code collapsed the tree view. Out of an academic curiosity, let's look at the page source behind this page. And as you know, there are no tree views in HTML. Somehow, .NET, the framework, has converted this conceptual TreeView control on the server side to HTML and CSS controls and JavaScript controls on the client side, it looks like a table. There appears to be a table. And I encourage you to make a glass of tea, put on some headphones, and read through this from end to end and study every line of it and learn in great detail how a TreeView is rendered as HTML, CSS, and JavaScript on the client side. And actually, I do not encourage you to do that. But you may do it if you like, since you can't stand in line at Chipotle right now. All right, let's close that. We're back in our Visual Studio project again. And let's break this. So I am going to, for a moment, switch over to the config class, and I'm going to mess up the connection string. Okay? I'm not going to let you see that, but I'm going to do it, so give me a moment here. I took out the password and the user login, the login name, from the connection string. I still know the database name, and I have a trusted connection equals no, and I have connection timeout equals 30, which seems fine. This is going to fail miserably now, but I just want to simulate an error message and see if we can deal with it a little bit better. So let's run it. Okay, we're going to run it in a broken state with no login credentials. And in that page load event, it's going to try to connect, but it won't have any credentials. And this might take 30 seconds to time out. We'll see. Eventually it broke. And here's what I got. It dropped me into the code because we're in debug mode. And I got an error that says the system cannot find the file specified. And the error is in line 50. Line 50 looks rather harmless. It's an open command, but it's an open command on the connection string object, which intuitively leads us back to a faulty connection string or something going wrong in the connection process. Your takeaway from this is that, hey, something went seriously wrong, but it's not very helpful if you look at this post-mortem. You're going to have to dig a little bit. And my advice to you would be that when something goes wrong with a database connection, always go back and start debugging the string. Usually the string is the problem. Now, where do you get a connection string? Same place we get everything these days, on the internet. Connectionstrings.com, a genius creation by somebody. I hope they got rich. Contains a myriad of connections for different kinds of data sources. SQL Server is right there. Once you've drilled down to SQL Server, you have to figure out what kind of protocol are you using. Are you talking to an ODBC compliant driver or an OLEDB compliant driver? Are you using a .NET library? You have to know that. Are you going to know that? Probably not. You probably won't have the flexibility of calling up your instructor and saying, what's the connection string? So while this may be helpful, my advice to you is to fall back on someone who knows the connection string. If you're at work, one of the things you should not be ashamed to ask, okay, there's things you do want to struggle with and figure out on your own. One of the things you should not be ashamed to ask is, what's the connection string? Because even if you guess one that works, you're probably going to leave out some parameters that you will regret, that may bite you down the road. So ask. If you're asked to write some code that connects to a database, ask someone for the connection string. You can't, you have a very low probability of guessing what it is. If you look at mine, here's something that we haven't seen. Multiple active result sets equal true. Now that is in there because I was using the same connection string to query the database more than once and having multiple queries open at the same time, and it was crashing. So after some research online, I found that parameter that I could set, and that'll let me use the same connection string and have multiple data sources open concurrently. And that solved a big problem for me. You may not put that in there, but down the road you may start using this connection string with multiple active result sets, and it will start failing. It's always in your best interest then. This is one of those little details that it's okay to ask about. Go find someone else who's connected to your database and ask them for a copy of their connection string. That's the best practice for learning how to connect to a database. Don't stress out over it. Certainly you want to be self-sufficient. A lot of things you're going to want to figure out on your own. This is not one of those things. I'm back in the code behind of the default web page. The connection string is still broken, and I'd like to make this a little more robust because, as we talked about a few minutes ago, there's no error handling in here, and it's not a well-written bit of code. Let's wrap a good chunk of this in a try-catch. And I will reformat this for you. I'm putting everything that's database related into a try-catch. The connection string, the connection itself, the submission of the query, and then the reading of the results that are passed back from the database engine. If anything goes wrong data-wise, that try-catch should help us. And in here, I'm going to add a response.write. I don't have a log file. I don't have a web page to land on if there's an error, so I'm going to jam in a response.write. It will show up on default.aspx, but at least it's a first step at error handling. So I'm going to say error reading data colon plus ex dot, and then I'm going to use message. This is going to go right into the HTML stream wherever the cursor happens to be. It's going to be a mess, but at least it's a first step at error handling, and we can refine it later. We're not going to get that yellow screen anymore. That's the good news. Let's cancel out of the previous execution. Let's start this running. Again, it's going to take a while to time out. Here is the error that we got. We trapped it with the try-catch. We wrote the error message to response.write, which is the response object sent back to the browser on the user side, on the client side. And the error message is not very good for a user to read. We would not want to subject any end user to this data, but it's a good debugging tool for us, and it keeps us out of that yellow screen. Eventually, if you fight through this, could not open a connection to SQL Server, the server was not found or not accessible, and then you're like, oh my goodness, how am I going to debug this? And yes, go back and start with the connection string. Figure out if the connection string is wrong. Is the host name wrong? Is the server name wrong? Are the credentials wrong? You just have some debugging to do. All right, we've demonstrated some error handling, very rudimentary. I went back in behind the scenes and I fixed the connection string, the program should work now. Can we just simply resubmit default.aspx? Remember, I edited the code on the server side. I edited config.cs. I fixed the connection string problem. Can I just resubmit the URL? This will be very interesting. I want to know if I can fix code that easily, or do I have to restart the program on the server side? The connection string is fixed. It's back the way it originally was. We're waiting to see if we get the error message again. You'll notice the little activity indicator in the upper left-hand corner of the browser tab. Okay, that went away. We didn't fix the problem because we're going to have to restart the app on the server side. No big deal, I just want to make you think about that. So even though I fixed the code, I've got to restart the app. Let's kill this app. We're back to square one again. Whoops, you're not supposed to see that. Let's run it. This should work. That worked. I fixed the connection string. I restarted the app. I browsed to the page, and all is well. There's employees, no problem. So let's look at one other thing that could go wrong. Sometimes the little debugging things we have to do teach us a lot about our code. Let's kill this session. And let's go back to the code behind for the web page. And we have this thing called command.text, which is simply the SQL statement, perfectly formed, that will be submitted to the database engine. It's my responsibility then to make sure that this SQL statement is properly formed. As I mentioned earlier, if I had made this into a view, I would have been a lot better off, because views are much easier to debug. There's a view design tool in SSMS, and I wouldn't be trying to build this thing by pasting a bunch of strings together. But since I did that, let's break it. Let's make a typo in here. Let's say we leave out the A in the second A in last name. So it's in quotes, meaning that it's hidden from Visual Studio. Visual Studio, C#, the compiler, they don't know there's a problem. It's a reference to a column name, an attribute name in the database table. There's no way that Visual Studio, the .NET framework, the compiler, can validate that. It's a hidden error that's only going to appear at runtime. Again, that's another reason why this was a bad idea, to create this query on the fly programmatically. It would have been a much better idea to build this using the view designer and store it on the server side. We all agree it's broken. Last name is spelled incorrectly. We're in the try catch block. We're going to see what happens. Is the program going to throw an exception because the query is messed up? Is the program going to submit the query, the database engine runs the query breaks? Will we simply get an empty result set? Or will we get an exception? Let's find out together. Let's run it. Remember, if we end up in an exception situation, it will go into the catch block and it will write into the response object. Good. So we kind of got something. We got error reading data, invalid column name, last NME, which is a great error. And think about where that error originates. That error originates all the way back on the server. The SQL server in a closet somewhere all by itself shed a tear because we misspelled a column name in the employee table. And that error was passed back to us, and we received that error in the form of an exception So the .NET framework realized that this query that we sent back to the SQL Server caused an error, it threw an exception, and provided us with the text of that error message. And we kind of got something in the TreeView, which is interesting. It looks like it populated one row of the TreeView, perhaps. I don't know what that is, but that's interesting. Good. Our try-catch block is effective. It keeps us out of the yellow screen. And we got a reasonably interesting error message that we can fix. We kill this session. We're back in the code again. And we know from experience now that the error is in this poorly formed SQL statement that we're submitting to the database engine. And hopefully we realize that last name is spelled wrong and we fix it, and that solves the problem. That brings us to the end of this video. Thank you for watching. I encourage you to study the code that I provided and see if you can make modifications to it. Remember, you need the VPN running. Go back and watch the whole thing again. Enjoy a wonderful burrito by yourself. And I will talk to you later.